In the next problem, we say that given that we have a symmetrically distributed or normally distributed set of data centered at a mu of 50.1 milligrams, what does sigma have to be in order to keep the population in this wing, that is a value above 52.0 milligrams per tablet, what does it have to be to keep this area down to 0.01% of the total population? So the question is, what is sigma? We know that the table connects areas in this shaded region to values of z, where z is the distance between the center and our value of x. So this is our value of x, this boundary that we're setting on the right. That is, the definition of z is the difference in mu and x, the absolute difference divided by sigma, is equal to z. So if we know z, we can solve for sigma. To get to z, we're going to have to use the area in red. We know two things, that the area in red plus the area in blue sum to 1/2. So the area in red is the area that we want in the table. The area in red then is 0.5 minus the area in blue, which is 1/100th, is this decimal equivalent of 0.01%, or minus 0.0001. So the area in red will have to be 0.4999. So we want to look in the table and find that area, and we don't have it exactly, but we have things that are very close. So these two areas are close. That means the z values that correspond to that, the z value that we want is going to be 3.6 plus some. So z is equal to 3.6 plus a little bit. The little bit will be the fraction of the interval in area that's represented by the fraction the little bit that we want is going to be the fraction of this interval, the interval plus a little bit. Plus a little bit. The little extra value that we want is going to be a fraction of the interval for z. 0.1 is the interval for z. The fraction will be represented by the fractional value of the area that we have. That is the difference between the area that we are interested in, 0.4999, and the bottom value for the area interval, 0.99841, divided by the area interval that we have, 0.499904 minus the lower value, 0.499841. So if we take those differences and calculate the ratio, we get a z-value of 3.6, and the next digits are 9, 3, 6. So sigma is equal to mu minus x, 50.1 minus 52.0, the absolute value of that, divided by the value of z we've just calculated, 3.6936. Numerically, that gives us a value of 0.514, and these would have the units of the same units as the average value, milligrams per tablet. So we would have to get our production process reproducible enough so that the standard deviation was as small as 51 milligrams per tablet.